All right, so type 5 of factoring is called mixed. You have a polynomial that is a combination of type 1, which is GCF, greatest common factor, and one of the other types, type 2, type 3, type 4. Type 2 were trinomials with a 1 in front. Type 3 was difference of perfect squares, and type 4 was perfect squares. So the first thing you notice is this is not a 1. It's like, oh, it's a perfect square. This is not a perfect square. 20 is not a perfect square. 20 is not something times itself. But what you notice is that these are all divisible by the same thing. So you have to factor that out. Now, are they divisible all by 2? Sure. But guess what? They're all divisible by 4. So you start with the smaller number and you write all the numbers that divide it. And we played this game before. And then you check them against the others. They're both divisible by 2, but they're also both divisible by 4. So my greatest common factor is going to be 4. So I'm going to divide it out. So that's step 1. Put the GCF in the front, divide by 4, divide by 4, divide by 4. If you need to put it underneath to help you, then do that. The 4's cancel here, you're left with x squared. 24 divided by 4 is 6. 20 divided by 4 is 5. Now, you cannot stop here. This, the part in the parentheses, factors more. This is type 2, right? The one in the front. So you're going to keep this 4 there. This doesn't disappear. You're multiplying this thing by 4, so you can't drop it. I'm going to factor what's there. So I'm going to play my game again. I'm going to put x and x. This sign goes first. This tells me that the both signs are the same. I multiplied a negative by a negative to make a positive. Now, you don't have a choice with 5. It's got to be 5 and 1. Negative 5 times negative 1 is plus 5. In the middle, you have minus 5. And at the end, you have negative 1x. Negative 5, negative 1 is negative 6. So it checks out. If you were to drop this 4, this does not match what you started with. That 4 has to stay there or it doesn't work. So if you were to multiply this all out, you'd get back to here, and then you would multiply by the 4 and you'd get back to there. All right, so 2 steps. GCF gets factored out. Then you continue to factor what's in the parentheses. All right, second example. You have y third, y squared, and y, and you're like, what? This is crazy. So again, this is, you have to it's hard to recognize sometimes which type it is. This is not type 2 because it's not y squared. And, this is not a perfect square. So the only thing you can do is the greatest common factor, the GCF. Now, you have a 1, a 5, and a 24. There is no number that divides 5, or 1 for that matter. There's no number that divides 5 that also divides 24. 5 is only divisible by 1 and 5. And 24 is not divisible by 5. So the GCF is not a number here. But they all have a y in common. So remember the game, right? That's really y to the 1. You're going to factor out the smallest power of y that they all have in common. And that smallest power is 1. So that's what I'm going to do. I'm going to put the y in the front. I'm going to divide it away. And again, if you need to do this, I'm going to erase it. Put the y underneath each of them. Y third divided by y1 is y squared. The plus 5 is not being affected by the y. Leave him alone. Leave him there. Y2 divided by y1 is y. This y and this y cross out, and you're left with 24. I'm lucky that I fit that there. So if you need to do the division, if you don't want to do it in your head, don't do it in your head. If you can do it in your head, awesome. So this divided by this here. This divided by this here. This divided by this here. You can multiply it and make sure that it works. Now, you're not done. This part still factors. The inside the parentheses part. This is, again, type 2. So let me put the y's down, right? Y times y is y squared. That will always happen. This sign drops down. I have a negative here. So I can't put a plus here. A plus times a plus is not a minus. So I have to put a minus here. Now I'll run through my pairs super fast. I'm looking for a 5. Different signs. When the signs are different, I'm going to minus them. So let me run through the pairs real quick and subtract them. 24 minus 1 is 23. That's out. 2 and 12. 12 minus 2 is 10. That's out. 3 and 8. 8 minus 3. Son of a bitch. It's 5. Yay. So 8 goes here. 3 goes here. I don't need to write the rest of the pairs. I got my hit already. So positive 8 take away 3 is positive 5 in the middle. Positive 8 times negative 3 is negative 24. So done. I know it works. It checks out. All right. So the third example. This one is much more complicated, and you got to be very careful with it. You're looking for the greatest common factor. Now, 25 and 100 are perfect squares. The problem is that 25 and 100 are both divisible by 25, so you have to spot that. But that's not the only thing that these have in common. There's an x, there's an x. Now, he's got a y, he doesn't have a y, so that I can't do. But I can take the x's that they have in common, and I take the smaller of the powers. That's my greatest common factor. 25 is divisible by 25. 100 is divisible by 25. X, x, but not y. He doesn't have a y, so you can't take y from him because he doesn't have one to give you. So step one is going to be to divide this into those two. So write it in the front. Now, we're going to be very sophisticated here. I'm not going to put it underneath this time. 25 divided by 25 is 1. X5 divided by x3 is x squared. Do you really need the 1 there? Hell no. You don't want the 1 there, don't put it there. Minus 100 divided by 25, right? There's a 25 under that. Divide it away. If you have to write it, write it. 100 divided by 25 is 4. X3 divided by x3, they cross out. Y squared goes along for the ride. Leave them there. Ooh, you should recognize that type. That's type 3, difference of perfect squares. So keep the greatest common factor, keep the GCF there, factor this dude more. Ready? It's going to be x and x. I need 4y squared, so I'm going to put 2y and 2y. One gets the minus, one gets the plus. It doesn't matter what order you do it in. If you want to put the plus first, knock yourself out. So GCF, factor it out, take what's left, keep going. All right, the final example, example 4, that I'm going to work on. This one is a lot nastier and it looks a lot more complicated. So we were discussing 18, 24, and 8. The largest number that divides them all, you look at the numbers that divide 8, which is 1, 2, 4, and 8. The only number that divides 8 that also divides 18 is a 2. 18 is not divisible by 4, and it's not divisible by 8. This number is, but this one isn't. So the largest number that you'd be able to divide them all by would be a 2. They're all even, so you can divide out the 2. Now, there's a y squared, and a y third. So again, you take the smallest power that they all have in common, which is a y. Now the question is, what about x? There's x, there's x. Oh, crap. He doesn't have an x. If this one doesn't have an x, then you can't factor it out. It has to be in all 3 of them. So step 1 is going to be to divide away the 2y. So again, if you want to write it underneath and divide it away, that's fine. I'm going to do it without doing that. 18 divided by 2, 9. I don't like the way my 9 came out. 9. X squared stays there. This y and this y cross out. Minus 24 divided by 2 is 12. X stays there. Y2 divided by y. Remember, if you need to do this, do this. It's okay to do this and cross out. That's fine. I'm doing it in my mind, okay? So y squared over y1 is y. Plus 8 divided by 2 is 4. Y cubed divided by y1 leaves me with y squared. Wow, that's crazy. That's a lot of shit. If you take this 2y and you distribute it and multiply him, you will get back what you started with, right? 2 times 4 is 8. Y times y squared is y cubed. That's how you know you did it right. Now, I'm not done. This will factor more, And you have to recognize what type this is, because this is a crazy one. You should look at this and say, I don't know what the hell I'm supposed to do with that. Well, this is type 4. This is a perfect square. Look, perfect square in the front, perfect square at the end, right? The first term, perfect square. Last term, perfect square. And it's positive. So to build this, I do something times itself to make 9x squared. So I put 3x and 3x. Something times itself, right? To make the first guy. Now I have to make the last guy. Something times itself to make 4y squared. So that's going to be 2y and 2y. Now the question is, what the hell are my signs? I know they must be the same. How do I know that? I have a positive here. This is either negative, negative, or positive, positive. So which one is it? Well, it's this one. Whatever sign is here, you drop into both. That's what a perfect square is. Something times itself with the same sign. Difference of perfect squares, the signs are not the same. That's why you have no middle term. I have a middle term. Now you're saying there's no way you get that. Let's see. You have negative 2 and 3 is negative 6xy. And then at the end of the rainbow, I have negative 2y and 3x. That's negative 6xy. Negative 6 and negative 6 make negative 12 in the middle. Remember, I told you when you factor this type, ignore the middle. Don't look there. Build the front, build the end, and the middle will take care of itself, okay? This is a special type, so you don't have to do that. So that's the final answer. There's nothing else you can do.